Hello and welcome to this lesson on valence electrons and reactivity. In today's lesson, we will look at valence electrons and reactivity and aim to understand how the arrangement of valence electrons in the outermost energy level of an element influences its reactivity, particularly in terms of the tendency to lose or gain electrons to achieve a stable electron configuration. We will then explore valence electrons and the periodic table and aim to recognize how these reactivity patterns are related to the element's position in the periodic table. So far, we've covered electron configuration and how elements are organized in the periodic table. You are already familiar with the idea that electrons are arranged in energy levels around the nucleus, and that elements are ordered in the periodic table based on their atomic number and electron configurations. Building on this foundation, today's lesson will deepen our understanding of how the arrangement of valence electrons determines an element's reactivity. Let's delve into how the arrangement of valence electrons influences an element's reactivity. Firstly, it's crucial to understand that an element's reactivity is largely determined by the number of electrons in its outermost energy level, known as valence electrons. Atoms tend to react in ways that allow them to achieve a stable electron configuration, typically by having a full outer shell of electrons. Elements tend to either lose or gain valence electrons to achieve this stability. For example, elements that have only one or two valence electrons, such as sodium, generally find it easier to lose those electrons. By doing so, they form positive ions, known as cations. They are positive because they have lost one of their negatively charged electrons, so there are more protons than electrons. This makes the balance unequal and means the atom is no longer neutrally charged. This occurs because losing these electrons allows them to drop down to a full outer shell at the next lower energy level, achieving stability. These elements are typically metals and are found on the left side of the periodic table, specifically in groups 1 and 2. Consider the alkali metals in group 1, such as sodium and potassium. Each of these elements has one valence electron. They readily lose this electron to form 1+ cations, thus achieving a stable electron configuration. Because it's relatively easy for them to lose one valence electron, these metals are very reactive. On the other hand, elements with 6 or 7 valence electrons tend to gain electrons to fill their outer shell, forming negative ions known as anions. This electron gain helps them achieve a stable noble gas electron configuration. Elements with this tendency are found on the right side of the periodic table, particularly in groups 6 and 7. Take the halogens in group 7, such as chlorine. These elements have 7 valence electrons and need just one more to complete their outer shell. Therefore, they tend to gain one electron, forming negative ions. This makes them highly reactive as well, especially towards elements that readily lose electrons, such as the metals in group 1. The periodic table is organized in such a way that elements within the same vertical column or group have the same number of valence electrons. This means they exhibit similar reactivity patterns. For instance, all alkali metals in group 1 have one valence electron and thus share similar chemical properties. They all react vigorously with water, forming the corresponding hydroxides and releasing hydrogen gas. Similarly, all halogens in group 7 have 7 valence electrons and tend to form compounds by gaining one electron from other elements. This pattern extends to other groups as well. For example, oxygen and sulfur in group 6 both have 6 valence electrons and typically form anions with a -2 charge by gaining 2 electrons from other atoms. This commonality explains why elements in the same group often behave similarly in chemical reactions. Understanding these fundamental principles helps explain why certain groups of elements are highly reactive, while others are more inert. By recognizing the number of valence electrons in an element, you can predict its reactivity and the types of ions it will form, linking this behavior to its position in the periodic table. In today's lesson, we delved into how the arrangement of valence electrons in the outermost energy level of an element influences its reactivity. We examine the tendency of elements to lose or gain electrons in order to achieve a stable electron configuration. This concept is key to understanding why certain elements are more reactive than others. We discussed how elements in the same group of the periodic table have similar valence electron configurations, which leads to similar chemical properties and reactivity patterns. This foundational understanding will help us make sense of various chemical reactions and properties of elements as we continue our studies in chemistry.